Good morning, grade 11s. Today we are going to continue to look at how to sort arrays as part of our chapter on sorting and searching arrays. Yesterday we looked at selection sort, which is a algorithm or a method to sort arrays in alphabetical order or from largest to smallest or smallest to largest. Today we're going to look at a similar but yet different method of sorting arrays, and we call that bubble sort. And the difference I will highlight just now when we look at our textbook. And then tomorrow and on Thursday we will be focusing on algorithms that can search specifically sorted arrays. So let's look at our textbook. Just to apologize for yesterday's activity, I'm asking you to do this one because we have not covered procedures yet. So again, my apologies. And today in the activity they ask again to write procedures, but I will specifically ask you not to do that, simply because we don't know how yet. All right, so bubble sort. Just maybe to recap our selection sort, I'm going to go look at this graph again because we're going to have a similar graph. With a selection sort, after applying our algorithm, it will ensure that the element in the first position of the array will be the smallest, depending obviously whether you are sorting it in ascending or descending way. But let's phrase it like this. After the first round of the algorithm, the element in the first position will be in the correct place, and then it will look at the second element in the array, etc., etc. With a bubble sort, it is the other way around. After the first round of our loop or our algorithm, it will be the last element in the array that will be in the correct position, and then the second last, and so on. So it is called the bubble sort because the elements will kind of rise to the top like bubbles as we swap them around. So the general algorithm looks somewhat like this. So we have two consecutive elements are compared, starting with the first two elements in the array. If obviously the one is greater than the other one, then they are swapped around. Very similar comparison is then made between the second and the third element. So instead of keeping or comparing the first one with all of them, we actually compare, we take the first one and then we compare it with the rest, which will then result in the largest element being in the last position of the array. Again, depending on whether you are sorting it in ascending or descending way. Okay, let's look at the pseudocode for our algorithm. So we find out how many elements we have to loop through, which is our number of elements minus 1, because we have to make room for comparing it with the last one. We do not have a nested loop. We're actually making use of a repeat loop. For that to happen, we need a flag, in this case be swapped, which indicates whether swapping has taken place for a cycle or not. So we will then loop for 1, to the end counter, which is the number of elements minus 1. If the adjacent elements in the arrays, if the one is bigger than the other one, then we will swap them around. Okay, and obviously this swapping, this is pseudocode. We need a variable that can hold the temporarily the value of the of our element k, and then we indicate that the swap has taken place, and we end the if, and then it loops through all the variable. And okay, if no, and then we decrease the end counter by 1, because now we're looping through here again. So you can see that the swapping has taken place, which will now loop through this entire process again until no swap has taken place and the loop ends, because b swapped is false. So every time it loops, we're setting the b swap to false again, goes through the entire process. If swap has taken place, it will be set to true, and it repeats that until no swapping has occurred. Therefore, array elements are sorted. You can have a look, but I'm actually not requiring you to do activity 3. Just read through those 5 points. Okay, so our ignore this again because you simply don't know yet, but we do need these variables. So instead of writing a procedure that's called sort names, you will just write this procedure on the click of the button, which you very well know how to do. Okay, and then here is our algorithm. So it's a little bit fleshed out from our pseudocode. Keep our names k, and then we write the next one into the previous one, and then whatever we put in the temporary variable, we'll now write into the next one. We indicate that the swapping has taken place. It loops, loops, loops. We decrease the counter, or you can say iCounter is equals iCounter minus 1 until not be swapped, or you can say until be swapped equals false. And here we go. Activity 4 for today, minus the declarations. You can use the maximum of 20, you know how to do that, but please ignore the procedures. Simply write a program with a button that will generate 20 random numbers. Okay, I'm going to write this here now. Use the function, add math to the users section. Add it to the users section, and then we can simply do the following, like random range, and then remember, and that's the reason why I'm writing this down, that only, comma, not an array, that not both numbers are actually included, so we need to, there's a semicolon still. So the first one is included, however the last one not, so we have to add 1 to it, which is 21. All right. This then concludes today's lesson. I hope that you know what to do. Ask me any questions that you have